David Smith here with another Flipped Classroom math video. A few tips before we start. Remember that you can slow down or speed up the playback if that helps you follow along. You can also pause the video at any point to catch up with your notes or try the problems before I explain them. Lastly, you could turn on the captions and read my words going along below the bottom of the screen. Today's topic, exponential growth. So now we're going to focus in on increasing exponential functions. So these functions typically are in the following form. F of x equals k times a to the x. So k is the starting value. Like for example, in a minute we're going to look at the growth of rabbit populations. Rabbits are known for increasing their populations very quickly. So we'll see how that factors in there. And then a to the x is the growth multiplier. This is what causes, or the math behind how it grows. Okay? Okay, so let's explore this growth of rabbit populations example. So you're going to get an equation for all of these kinds of situations. This one is the population of rabbits, which is the number of rabbits that we have, is given by this equation. P equals 100 times 2 to the t. So let's take a look at what we've got here. 100, that's my starting population from there, okay? 2 to the t, t is the time passed in months. Now, what you know from our previous work here, this is a doubling function. Our base is 2, so each time the month increments, in other words, the month increases by 1, we're going to multiply by 2 one more time. So it's going to double again. So in a way, this is saying the population of rabbits doubles every month. That's fast growth. Okay, now let's look a little bit more at this. Starting population. Think about how that works. At the start, what is time? What is the number of months that have passed? If you thought 0, you're right, because we're right at the start. We haven't allowed any time to pass, so we're at t equals 0. The number of months equals 0. So if we put a 0 in for t, we get 2 to the 0 power. That's just 1. So 1 times 100 is 100. So that makes sense. Our starting population is 100. If we put in 0 for our time, which is when we start, we are going to confirm that and get 100 from our function, from our equation. Okay, so let's answer some questions. How many rabbits after 3 months? So this is just a plug-in. P is going to equal 100 times 2 to the third power. Now we know 2 to the third is 8, so that's 100 times 8, which is 800 rabbits. So pretty fast growth, right? I mean, we started with 100 rabbits, we waited 3 months, and now we have 800 rabbits. That's really big. So let's take a look at 6.5 months. Oh my gosh, that's going to be a lot, right? P equals 100 times 2 to the 6.5. So I want you to pause the video right now and get out your calculator, okay? And I want you to figure out on your calculator how to do this math. This is a little hard to do by hand. 2 to the 6.5 power is not an easy one. But on your calculator, you probably have a key that's y to the x, like that, or else you have a caret key that lets you put in the first number, 2, and then the second number, 6.5, and it will do that math for you. Another word, exponents always come first. So when we do this math, you'll notice up here, I did 2 to the third first, got my 8, then multiplied it by 100. That's order of operations. Don't do 100 times 2 and then raise it to the third power. So in the same way with this one, you need to figure out what 2 to the 6.5 power is, then multiply that by 100. And if you did that, your answer is 9,051 rabbits. My gosh, that's a lot of rabbits. Okay, I have a problem for you to try. And I really, really want you to pause the video once it's all set up and see if you can do this one. Okay, same situation. We got a bunch of rabbits. Actually, we're going to only start with 2 this time, but it's the same function. Okay, so they're going to double. They're going to double every month. So calculate how many rabbits do you have after 1 year. Okay, So our starting number is 2 this time, but the function is the same as it was before. So see what you can do. Okay, so I'm going to put the equation up. The population would be 2 times 2 to the t power. So that would give you, that's the basic equation. We start with 2. We have our doubling function. So in 1 year, what do I put in for t? That's going to be population equals 2 times 2 to the 12. Remember, t was months. Okay? So now get out your calculator and see if you can do this math. Okay, so if you got 8,192 rabbits, you're correct. Now this is what they mean when they say breeds like rabbits. We started with just 2 rabbits. A year later, we have 8,000 or more than 8,000 rabbits. That's crazy. Okay, let's do an example with a slightly different critter. Okay, so this one is a plague of locusts. And if you don't know what a locust is, it's basically a giant grasshopper, which is an insect, and they like to eat. They eat plants, and they eat crops. And they're actually a problem in areas where lots of crops are grown. A plague of locusts is like a huge swarm of tons and tons, millions and millions of locusts, and they show up, and they're just going to eat everything in sight. So if you're a farmer, this is the last thing you want to see on the horizon, is a plague of locusts coming up. Now, they eat and grow and reproduce. So the amount of land that they eat, or crops that they eat, increases exponentially. So we can model that with an exponential function, which is what we're going to do in this problem. So what we have here is our equation is the area of land eaten. This is how much they've eaten, is 8,000 times 1.4 to the n acres. Now, if you're an international student, acres is one of the weird, like American/English measurements for land area. It's just, you just have to get used to the strange American system. But it's an area, it's a unit of area. N, in our function, that's the exponent itself. That's the number of weeks that have passed. So each week, it's going to multiply by 1.4 again. Okay? So this is not a doubling function. That would have to be 2. It's a 1.4ing function, if you wanted to call it that. Okay, so I want you to answer some questions here. What is the initial area? This is when, before time starts marching on, this is when the number of weeks equals 0. What do you think? That we get right from our function. And you can know that if you just know this number is the initial amount, you'd be able to put that in there right away. However, if you wanted to do the math on it, you just put in 0 for n. 1.4 to the 0 power is just 1 times 8,000 gives us 8,000. So this is 8,000 acres. Okay, you're going to need your calculator for these next 2. How much is eaten after 4 weeks? The equation for that is 8,000 times 1.4 to the 4 power. So pull out your calculator and do that. It's pretty big. That's 30,733 acres. So just after 4 weeks, we've increased this amount of land eaten all the way up to 30,000 something. That's a lot. Okay? Now try after 7 weeks. It's going to be even bigger. 8,000 times 1.4 to the 7 power. So again, get your calculator out, plug in the numbers, see what you get. I get 84,331 acres. That's a lot. You don't want to be a farmer when that's happening, okay? Now, if you're having trouble making your calculator do these calculations, bring it to class and we'll figure it out. One more word about these problems. You probably noticed from the rabbits to the locusts that we're doing word problems. So I find that as I teach this unit, people struggle with those. The math isn't terribly hard. We're not doing a pile of algebra and moving equations around and doing tricky solving. We're just analyzing word problems so we can plug the right numbers in the right places to do the calculations. So please read the problem carefully, look at your notes, and then do your best. Now that you've finished watching the video, take a moment to jot down any questions you have so you can bring them to our next class and get some help. You can also watch the video again to perfect your understanding. If you enjoyed it, please click the like button down below, and if you'd like to help me grow my YouTube channel, please click subscribe.